I just wanted to share this video on how to make a very simple opto compressor. This is the opto compressor works by basically the music that's playing or the audio that's playing. When the signal gets high enough, it turns a light on. The light shines on a photoresistor and lowers the resistance of the photoresistor, and they use that as a feedback mechanism to lower the audio signal. So I just made a very simple one out of basic transistor concepts. This is just an amplifier to amplify the signal. There's a little threshold control. This is a potentiometer down here. I've got it set to high right now. Goes through an amplifier. That amplifier goes to turn on this transistor as a switch. When that turns on, this LED is coupled to this photoresistor. It's in a little heat shrink tubing. I'll show you how to do that later. And the amp amplifies the signal, turns on the LED. The LED shines on this. Then it lowers the resistance in this bottom leg of the voltage divider. So when the photoresistor is very high and it's dark, then basically the signal goes through. Almost none of it goes this way. When this is lowered, then this voltage divider becomes more important and lowers the signal. Of course, so the signal goes through here, through the voltage divider. It also gets amplified here and lowers it when it reaches this threshold. Of course, we have to hook this up here. And that's it. Yeah, I'll just make a note here. This transistor is a switch. Basically, when the voltage gets to 0.7 or 0.6 in that volts, when the voltage right here at the base gets up to 0.7, it turns the transistor on and current flows through here. Now, this amplifier, we'll just run it here. You'll see that it's I've got it kind of sitting that it's 1.3 volts or so. Right here is the baseline. So that 1.3 volts is already above the 0.7 threshold. So if we hook this amplifier up to this transistor switch, it's going to be on all the time. Well, we want it kind of flashing. So I put this in there. That forward voltage of this is 3.2 volts, something like that. So we want to make sure when this voltage here goes up above like, I don't know, 3.5 or something like that, it's going to turn this on. Now there's an extra LED here. That's an indicator light. I just want that indicator. I want to see when the compressor is turning on. So it's just a simple light. So it's a fairly simple circuit. There's actually more to it than this. I mean, this is an inverting amplifier. It's a half-wave compressor. There's some other things I'm kind of skipping over here. But basically, long story short is this amplifier turns on the LED kind of to the music, so to speak, or to the audio. And you can adjust how easy it turns the LED on. LED shines on there, lowers the voltage through here. Let's just take a look at that. I've got this voltage going from 0 to 1 volts. You can see that here. Now here's the voltage divider. See, this is when there's no light going through here. It just kind of goes through. When the light shines on there, this is going to go down, and you'll see this voltage drop here. That's the signal. This is the voltage dropping there. It's probably like a 4-to-1 compressor. This is you can get the compression ratio out of these two, and this is more of a threshold control. There's no attack or decay on this. You know, if you add like a bypass capacitor here and maybe like a pot here that you can adjust, that'll help you make this maybe a little more sensitive if that's needed. So I will build it and we'll test it out on the oscilloscope and listen to it. Okay, I'm going to make one slight change just so I can eliminate this, you know, one less part. I'm going to take this out. I'm going to put this LED down here. It should basically cause the, well, should behave pretty similarly. It should turn on about the same time. Not exactly, because forward voltage is kind of dependent on, to some extent, dependent on the current going through it. And there's going to be more current going through here. But anyways, it should behave pretty similarly. And that gives the circuit one less part, so why not?
Alright, the yellow is the input signal, the blue is the output signal, and they're both kind of sitting on top of each other. You know, you can separate them if you want, but let's see. So I'm going to turn up the signal to the threshold is like on 50% now. We'll just keep turning this up and look for that light to come on. Okay, light comes on, and you can see the signal starts ducking a lot more. Then after that, the output signal is lower. So it seems to be working okay. Let me see. If I turn this all the way up, just out of curiosity to see where it triggers. There's 0.1 amplitude, 0.15. Okay, so it comes on around 0.2, which is pretty good for low-level signals. You can see its light's really on there. So it seems to be working. I'm going to separate these also, just in case there's a problem with you seeing it. You can see the lower waveform is not as strong. Let me turn this back to 50%. Okay, there we go. There we go. You can see it kind of duck, and that's doing that at about, like, looks like around 0.55 volts. Yeah, 0.5 volt amplitude. Anyways, we'll try it with some music and see if you can. Anyways, seems like it works. I'm pretty happy with it for being so simple. I'm gonna rewind this. And if you're interested, here's the board. It's kind of hard to see. It's not a great soldering job, but anyhow, it's what it looks like. We've got the this is a ratio control, and there's the threshold. I have the voltage divider kind of hooked up separately because I'm going to test this out on a preamp that I'm adding compression to, and it already has more or less that resistor in it.
Okay, so we tested this. I never actually did need to add anything there, so I'm just going to take that out. Pretty satisfied it was working without that. The thing to know here is, well, you know, we were using an iPhone. It was a low impedance input, and I think a lot of people would probably want to use this for guitar. It'd be a common application. So I'm going to rework this a little bit. Give me a few minutes, and basically what I'm going to do is just put emitter follower here with a pot. I'm going to lower this down to like 10K, so we'll get like a meg input, 1 meg ohm input impedance, and output impedance of about 10K, which would be more usable for you know, more applications. I'm just going to get rid of this attenuator, and here's a little circuit I built. This is basically like emitter follower, they call it. And let me sort of hook this up. Okay, so got the signal going in this emitter follower. Bear with me for just a second here. Okay. And we're going to have to put tell you what, we're going to have to put one of these capacitors here. Let's see. Alright, so we've got the signal going through this emitter follower, and this is like a pot. I'm going to actually hook it up like this. So this emitter follower, I'm going to use this as like the threshold control. And in fact, I'm going to do something a little different here. I think I kind of hooked this up wrong. Or at least this would be a better way to do it, just like this. Whoops. Okay. Sorry about this. Okay. So, I think we've got this right now. Okay, this is going into the emitter follower. This is going to be just a copy of the signal that comes out of the follower. This is, you can use the wiper here to adjust the threshold of it going into this amplifier, and that should do it. Now, I want the output impedance to be a little bit lower, so do this. So we have an input impedance of 1 meg input impedance. Output impedance is 10K or less. So that makes it usable as like a pedal or something like that. Of course, this is the photoresistor. So we'll give this a try and kind of go from there. Okay, so I noticed when more or less, like if I let a note ring and it just barely was keeping this light on, you could hear a little bit of distortion. I think what's going on is when the LED is just barely coming on a little bit, this photoresistor's probably like 20K resistance or something. And I sort of tested this. I just adjusted it so it was just coming on, and it's kind of around the same resistance as this. We really want it dropping a lot more, at least for this style design. So what I did was I looked through a bunch of photoresistors and I got something that I think will work a little better. Basically, you kind of want it, you want this photoresistor when the LED's on to be like less than 10 times this, I would say. And when it's off, you want it to be greater than 10 times that, at the very least anyway. So I'll show you on another screen, but basically I had one that's not nearly as, doesn't have nearly the same resistance. I used a 5506, and then I put this back to 22K, and that did a much better job. You know, it's very hard to hear any kind of distortion at all. And it's pretty clean. I was very happy with it. Under certain circumstances, if you really let a bass note ring right at the right at the threshold level, and you wait for it to duck out slowly, I mean, sometimes you'll hear a little bit of distortion. These are things that you can sort of adjust the compressor to compensate for. Actually, I thought it sounded really good for the most part. So to recap, I put this back to 22K and just lowered this photoresistor 5506, and I am using a red LED just because I happen to have those, and I'm going to try a white one out sometime, but this one seems to work okay. Yeah, something else to think about is maybe lowering this resistor and getting some more current to go through there. So there's a few things to be tweaked, but I would say, like, as is, this works pretty well. It's going to have about a meg input resistance, about 10K output, which makes it useful for a pedal or for a lot of different things. Okay, I ended up going with this 5506 resistor. It looks like it's 150K dark and 2 to 6K light. Now I've found this to measure a lot different. Mine's much higher than that and goes lower than that pretty easily. Of course, I'm shining the LED directly on it. So this is the one I used. It sounded much better.